Hello, today we're going to solve the problem of the day from LeetCode. In this problem, they are giving us a string and also a dictionary. They are asking us to split the string into the words that are present in the dictionary, but in a way that we can minimize the characters of the string that are not covered by any word from the dictionary. For instance, in the first example, in a way to achieve that is splitting lead, then s, then code. In that way, lead and code are present in the dictionary, and the only char that is not present is s. In that way, the answer is 1. And the same for the example 2. In this example, we can split into say, hello, and world. Then hello and world are present into the dictionary. In that way, only say is not present, and for the reason the answer is 3. Okay, we also check that in this case the largest length of s is 50, and also the largest length of the dictionary, and also the largest length of any word inside the dictionary. Okay, then we see that the largest values are not so high. That means that we can go for some approach related to brute force, because we have not very limited in this problem, because the constraints are not very elevated. But usually when we have a problem that is solvable by brute forcing, we can also use dynamic programming. In that way, we are going to use dynamic programming to solve this problem, and the intuition behind doing that is that, for instance, let's assume in the first case we have this as a string, and then our dictionary include LeetCode and LeetCode. We can say, okay, let's assume that usually also for approaches related to dynamic programming, we use in the dynamic programming vector one more in the length. That means that we are going to start our, let's say, of the p vector with 0, but this initial value won't cover any of the chars. After this index, then the chars of the string will start. In a way, we can see that our initial status for the p will be like assuming the worst case. And what is the worst case? The case in where we have like basically that we cannot include all of our chars until the current char into some word of the dictionary. That means that the initial value of the p will be like the length until that corresponding index. This is the worst case in which we cannot put any of the chars inside words of the dictionary. But we can improve this, because for instance, if we have that for instance, this lead, we have this present in our dictionary. That means that we can put this update this value here to 0. That means that if we start now solving the problem from this letter, then the only important thing will be checking what is the minimum or the answer that we can get for the remaining string. And you notice that now basically this is the same problem but with a shorter string. And we can also at the same time, now that we have reduced this to 0, then in the worst case this will be 1, because it's 1 assuming that this character is not included in any of the words of the dictionary, and then 2, and then 3, basically the same that we did for the base case, for the base worst case. But then when we are in S, we can see, oh, but code is also included as answer. sorry, in the dictionary. That means that we can like also move this one until here, and in that way we know that the answer basically will be like the minimum in our DP vector. The problem will be reduced to, in this DP vector, find the minimum value for each of the indexes, and then the answer of the problem will be the minimum DP value or the DP value of the last index. I hope that the explanation was clear, and now we're going to start with the coding part. We are going to store the length of S. We're going to use iota, that is basically initializing in the way that we want. And then we are going to start traversing the string S. And then we're going to traverse the dictionary. And we are going to store the length of the word. Because also we need to check if, like, from the current index we can start and build any of the words that are inside the dictionary. We also need to check that we don't like get out of the word length of the string length. Basically here with this if condition we're detecting that in our current index we can build the current word of the dictionary, and we are traversing each word of the dictionary. We're going to start the increasing from the word length from the e plus word length, that is basically the index of the end, or let's call it end index to be clear. And you're going to start the incrementation with the current value of DP. But this is not making any sense, because we need to check and do the replacement only if it minimizes the value. We are using this because we need to like start increasing one by one, and that basically will depend on the value of j. If j is higher, then we will get a higher difference there. That will get this stepwise incrementation. Then the answer will be the length. Okay, let's see. Yeah, for the first we have like correct that the answer is 1. And then let's test with the second case. Yeah, also we have the answer correct. Then let's send our implementation. I copied wrongly. Yeah, then let's submit it. Yeah, and the solution is correct. I hope that the explanation was clear. If not, let me know.